Well, welcome. My name is Rob Doubleday. I'm Executive Director of the Centre for Science and Policy. As many of you know, the Centre is set up to try and broker links between people working in public policy and expertise of researchers at the university. And we've done that through trying to build and establish networks between these worlds. And we're very pleased to see a few of our policy fellows here this evening, so there's two at the back. In addition to doing this practical job of building these networks, we're now turning to build up research on these networks of evidence and expertise for public policy. And we hope that these activities will be mutually reinforcing and supportive of creatures of the Enlightenment that we are. We think that if we better understand what we're trying to do, we might be able to do it better. And one of the ways that we are doing this is to begin a program of bringing in world-leading thinkers about the relationship between evidence, science, research, and its the contributions it can make to policy and practice. And the very first of these visiting research fellows, we're delighted to say, is Professor Charles Kennel, who gives tonight the sixth of 6 lectures on climate change adaptation, looking at a series of questions about what the science tells us about climate change and linking that through to what the implications are for Act Today. We're very grateful to Charlie for being our inaugural visiting research fellow, even guinea pig visiting research fellow, I think sometimes could say. But with that, I would just thank you for coming and hand over to Charlie for this final lecture.
Well, thank you very much, Rob. Can you all hear me? Yes, thank you. Before we get started, I'd just like to give a special vote of thanks to David Cleveley and Rob for the Center for Science and Policy, and to Frank Kelly, and to Claire KitKat, who's helped quite a bit in hosting this lecture series, and me. So I'm very deeply grateful to them, and I'm deeply grateful to you. Some of you have sat through all 6 lectures, and I can't imagine how you did it. But anyhow, there we are. So now I'm going to go back and review a little bit of the 6 lectures. I think the biggest reaction that I've gotten from people who commented later was, we didn't know how big this problem is. And I actually, in thinking about it, realized I didn't know how big this problem was until I sat down and tried to put its pieces together. But I think Ban Ki-moon does, and I'm going to try to convince you that this big problem, this 1,000-year problem, the journey of these 1,000 years will begin with a few small steps, some of which I will try to convince you make sense. I can't obviously review everything from 6 lectures, so I'm only going to pick out the things that I think contribute to the point of this lecture. So now see if I can get this. Aha! The first, by popular demand, I'm going to bring back. Let's see. There we go. This is Richard Muller's analysis of the global temperature from 1800 to the present time. He compiled this in order to deal and put to rest the great scandal that beset the climate world about 5 years ago in 2008 and 9. When the famous hockey stick graph was debunked, if you will, by people who crashed into their internet. So he put together all of their objections and found them, when you analyzed enough data, that none of them were valid. So now you're just seeing the world as it was in 1879, height of British imperialism. What I want you to look at is not the way the temperature goes up and down, but look at how regionally specific it is and how variable it is. And so when people talk about the global temperature changing, they mean something like this. They don't mean something like this, but we need to think of it as something like this. And in fact, when it goes forward in the future, it will be like this. And so now we're in about 1930. Second World War is about to begin. And you can see the temperature, the land temperature varying. We're now in the mid-century hiatus in warming, which we think was caused by air pollution from North America and Europe. And now we've entered the last 40 years of warming. Notice how it looks. So if you're going to be dealing with adaptation to climate change, this is what's going to happen to all the people and communities in these regions. And you can also see how it's possible for honest people living in different places to disagree about the severity of the problem. Now, the next thing that's important for adaptation in particular is that certain geophysical systems, and particularly in the Arctic, have been strongly affected by the climate change, and they're changing at a rate that is at least twice what we are observing at mid-latitudes if you measure it by the global temperature change. And so this is the sea ice area as it was first measured in 1979, and you can see it's measured in September. And well, there it is. It looks more or less about the same. But I'd like you to consider the last decade, which we just went through. Now watch what's happening. So there we are at 2007, and the last set of data in this set is 2012, and the sea ice area has been reduced by 40% relative to the average that used to prevail. But what is even more disturbing, and you can't see it in a diagram like this, is that the ice thickness has been reduced to about 25% of its historical total. That's going to measure how much there is that's left. And I think nearly everybody would agree that most of the changes have occurred in the last decade. So what we now understand is that there's actually a reconstruction of the drivers of the climate in the polar regions, particularly in the Arctic. And this can be found out by comparing the Arctic assessment of 2005 with the snow, water, ice, permafrost assessment only 6 years later. And they found a completely different structure of the warming pattern in the Arctic over that 6-year period. And so we know now that a regime change in the climate is in progress, and it's fairly clear from the way it's behaving and from recent measurements that Scripps just made, Ramanathan and his students, that this is due to the fact that when the ice melts, you replace white surface with dark ocean, and this is increasing the warming rate significantly and faster, I think, than people at least intuitively expected. Now, the same thing seems to be happening, at least as measured by ice melt from Antarctic, also Greenland, in which they've recent assessment showed that decade upon decade, the ice melt rate went up by about a factor 5 in the Antarctic. And when the last assessment was made during the period 05 to 7, it confounded the assessment. The rate of change of the ice was so fast that people couldn't decide on what it was. Now, this is terribly important because people want to know what the sea level rise rate will be in the future so that they can make engineering and land use policy plans and the like. And it's quite clear that things are changing sufficiently rapidly there that if this kind of rate of change should continue for, say, another decade, then it will be the case that the contributions to sea level rise from the ice melt in the Antarctic and Greenland will rival that of the warming itself, and it is a factor that is increasing more rapidly than the warming. So there's issues here that we have to pay a deep attention to. The other parts of the lectures that were more theoretical in nature, I just really want to summarize for you briefly. First, we're not going to be able to avoid long-term climate change. This is because 90% of the heat added to the ocean by anthropogenic sources is going into the ocean, and the ocean has a release time of about 1,000 years. So no matter what we do, we've bought 1,000 years of climate change that will at least be measurable, and the question will be, how dangerous will it be? And we have a choice about how dangerous it will be in the long run, and that is related entirely to fossil fuel burning and greenhouse and CO2. But at the same time, we also have to think about the short term, because as I've argued on a number of occasions here, the near-term future is the only one that we own. It's the only one that we can take steps to deal with. And so this summarizes a couple of papers that we wrote. The case for adaptation, I argued in our third lecture. We asked the question, what can we expect if we meet the CO2 targets for stabilization? We also act on the short-lived climate pollutants, which can help in the short term, but we also assume that by 2050 the world, China and India, will have cured their air pollution problem and removed a cooling agent. So if you put all that together, it appears that even if we try everything in our toolbox that we know about, it's going to be hard to keep warming in 2050 below 2 degrees centigrade. That 2 degrees was a target not chosen by science, but chosen by diplomats, but it has become a term of art in the policy community. But if we just take that as a lower limit to the warming, we're going to get 1.2 degrees additional warming by 2050, when we got 0.8 degrees in the last 40 years in Richard Muller's plot. So we can expect then that the warming rate should just about double. That is to say that the global warming rate that we will encounter in the 2030s to 50s will be comparable to the one that is seen today in the Arctic. Okay? So that's the reprise, and now I'll go on to the part that I'm most nervous about, which is I'm going to try to suggest a few ideas for us to think about on what to do. So the first thing to do is to adjust the way we think about the climate in light of the approaching and accelerating adaptation demands that will be placed on our societies. So I'm going to deal in succeeding PowerPoints with these issues: policy balance, adaptive management, more forgiving way of thinking, adaptive management and governance, knowledge action, and so forth. So we'll just move on. I regret to say you're going to get a torrent of slides. I've tried to say everything in this last lecture, and if I go too fast, you can ask me questions later. So policy balance. This has been a topic of concern, I think, in the climate community since about 2007, when the last AR4 assessment came out, together with its great weakness and its inability to comment appropriately on sea level rise. Earlier than that, many people who were really concerned with this problem really disparaged talk of adaptation. They felt that it absolved the emitters, the gross polluters, of their responsibility to mitigate. And of course, it's not too great for morale to admit that you've lost the carbon battle and that you're not going to be able to stabilize it over the next 1,000 years. Now, mitigation and adaptation make entirely different demands on the world of policy and decisions. CO2 mitigation policy, which determines our very long future, it focuses appropriately on measures of global reach, greener technologies, macroeconomic, regulatory, and innovation incentives. Adaptation, on the other hand, is about local resilience, and it focuses on regional issues that are already here but will be exacerbated. Now, this means then that when you do assessments for mitigation and adaptation, they have different audiences and different requirements. IPCC, as we'll see, was designed to support a small number of very large decisions made by a relatively small number of central decision makers. On the other hand, adaptation will be required for hundreds of regions and thousands of communities and organizations. Totally different audience for the thinking process called assessment, which we are used to from IPCC, but less used to on the regional adaptation scale. So the first and most important thing to say about adaptation, which I will focus on henceforth, is that we are entering a world new to human experience. We made this clear, actually, in two ways during the lectures. First, we compared our present situation with that prevailed over the last million years during the Ice Age, and we saw the rapid change, unprecedented change in carbon dioxide concentrations, which has to have a major effect that will take us out of the equilibrium that was reached 4 or 5 times between ice ages. So that is new. The other thing that's new is that when we looked at and examined the assessments that were made, particularly the World Bank assessment that looked at the world at 4 degrees, we actually discovered the properties of a world that would be extremely different from the one that we lived in. There will be regions where the average temperature during the summer will exceed the highest temperatures encountered in heat waves during the 20th century. So how do you deal with a world that you've never seen before? We argued that the only approach that can work and is practical at the present time is adaptive management. So it's what you do when you know you have a serious problem. You can't put it off, but you don't know how it will unfold. And so at the bottom of this slide, there's a few watchwords that I ask you to remember. You can boil the adaptive management cycle down to 3 words if you'd like. Assess, decide, act. Assess, decide, and act. Keep doing it. And for adaptation, then I think the watchwords are to think globally, assess regionally, and you'll see what I mean in a bit, and act locally. So if you adopt an adaptive management strategy, it calls for a different approach, a psychological approach, that differs somewhat from considerably from the hard-edged absolutism that afflicts the carbon problem and the climate debate thus far. So be practical. Do whatever you can when you can. Take progress where you find it. Be reasonable. Allow for mistakes. Tell your decision makers, yeah, we might make a mistake, but if we adapt, if you assess frequently enough and we adapt frequently enough, we can correct a mistake before things get out of hand. If we ignore the problem, it might. Be tolerant. No one size fits all. Every region, country, entity have different technical capacities, social and the like. Nations, be tolerant. They're going to try to solve this problem at different ways and at different rates. Be timely. Don't delay the decision. Keep coming back with your assessments. Be vigilant. Look out. The one weakness to adaptive management is that you might approach a major and sudden change in the system that is so serious that it's hard to deal with. Those are in the trade are called tipping points. And I suggest that while adaptive management, lots of sequence of relatively small decisions reviewed may not work for tipping points, the adaptive management philosophy keeps you vigilant because you're looking for the precursors at all times. And then finally, since the problems can be with us, build enduring institutions. So now, when I was at our little student seminar, the reading group the other day, I invited them to come and watch me self-destruct. And that is because I'm going to wander out of my field and use the governance word today. And I know that my social science colleagues, when they think about governance, all sorts of images pile into their mind: intergovernmental agreements, treaties, regulations, NGOs, stakeholder consultation. They think of all kinds of things that could and evaluate the ways of approaching the management or making decisions about the climate. I'm just going to use the blank term governance in rather general, and just assume that there are or will be entities out there that in the strong case actually make decisions, but in the weaker version they guide the evolution of outcomes. And so then when you see that, and I also use the term decision maker rather generically, but when you see that, you see now suddenly there's a relationship between assessment and governance that is unique in the world of climate, because we are in a world where the intuition about the past is going to fail the governance mechanism. The decision makers are going to have to rely on assessments, whether they like it or not. So in that case, assessment and governance are inseparable. And each needs the other. They're different, very different, but they need each other. If you design an assessment regime, that constrains the governance regime if they agree to look at the issues that come up in assessment, and vice versa, a governance regime can constrain the assessment to what it is possible for them to decide. So there's a kind of reciprocal relationship with the two, but they are inseparable. Now, here's where we're going to try to use the think globally, assess regionally, and act locally. Assessment's job is to bridge knowledge and action. And so on the bottom there, I kind of look at in some ways, who governs the think globally, assess regionally, act locally. Where's the governance? So at the moment, scientific knowledge is managed by a loosely organized club of advanced nations that make much of the knowledge freely available. At present, our experience with regional assessments, the governing bodies of those regions or entities, political entities, actually invite the assessment. And they ask the experts to come assemble the knowledge and deliver the synthesis in useful form. Act locally is the more problematical part of this sequence, as you will see. But really, within regions, the communities eventually going to have to make and interrelate complex, multidisciplinary, geographically distributed decisions. The changes in the environment are going to interact with one another. And Elinor Ostrom, the great economist, ecologist, foresaw this problem, and she gave it a name, polycentric, for this kind of decision-making. And it is this kind of decision-making that I anticipate will be necessary for adaptation. So the question then is, how does knowledge support action? And so I'm going to try to convince you that as part of the solution of the problem, that adaptation calls for a consortium of knowledge management services that support via the assessment and other processes the polycentric decision-making that will be required to make adaptation decisions and coordinate them across regions. Now, some of you are going to react and say, isn't that kind of hegemonic? The advanced world is going to embed its philosophy into an automatic system that will then control the minds of the developing nations. And this, of course, we have stumbled by saying that. We have stumbled on to adaptation's primary ethical dilemma, which, as everybody must understand, the countries least responsible, least able to adapt, are the ones that are going to suffer the most. And this has led to a very bitter and unresolved dialogue in the international community, which has not been settled. It's unlikely that the developed nations will, in fact, keep their commitments to fund development adaptation at the scale needed. However, and this is, I think, the reason is that these incentives are misaligned. Countries are very selfish, they're not idealistic, and there's very little incentive for both sides to solve the problem. And this ethical dilemma has paralyzed, in my view, action that could have taken place in the developing countries and hasn't. So I think there's a possibility that the developed and developing world will find a mutual interest in some sort of global knowledge action network for disaster management and adaptation. On the advanced country side, we're suddenly discovering we have big problems ourselves. They're going to be expensive. And so we will keep that system going for our own needs. But I cannot imagine that developing countries faced with disasters and so forth would refuse help. And more importantly, they want to know how to help themselves. And this debate has inhibited that kind of initiative, in my view. So there's really going to be very different ways of approaching this problem on the two sides, but they may both have an interest in going forward, in connecting up. And as I say, it won't solve everything, but maybe it will help. So looking at that then, let's return back now to the question of how are we going to make assessments that will try to deal with this architecture. I probably look like I have to rush through again. So what have we learned about assessments for adaptation? So I'm going to review the items that are on that list there. I won't dwell too long on that. Our experience base now is sufficiently broad for us to see the outlines of what's involved in making an assessment, but it has all been done in countries that are not only developed but have their own very strong scientific capabilities. So, but they do connect up differently to their governance. The Arctic Assessment reports to the International Arctic Council. The UK assessment reports to the national government level. California assessment reports to the regional level. And an assessment that we did in Venice speaks actually to the actual organization that will manage water, the Magistrato alle Acque in Venice. So, having done that, then we can begin to take an assessment. Just isn't a book that comes out, it's a process that makes it. And you can begin to divide the assessment process up into a number of components. You can choose another way if you'd like, but I choose knowledge management. These are all knowledge management processes: assembly and synthesis, certification, translation, and delivery to the governance regime. So knowledge assembly and synthesis, you might think of it as part of the think globally, assess regionally, act locally mantra. The global science does set the stage. It then filters, it sets the background and expectations, I think, on what will happen at the regional level, where the specific impacts to geophysical and human systems will be estimated, but it's the local knowledge that shapes their own political objectives and provides, through their knowledge, the objectives at the regional assessment level, some of the objectives thereof. So that's assembly and synthesis. Here's knowledge certification. I think, and many people probably do, that IPCC's most important value-added product is knowledge certification. It attempts, with some faltering success, to deploy the authority of science behind these statements. So every statement is deeply considered, extensive literature review. There's an informal ranking of reviewers by reputation. The conclusions they reach are made in exhaustive and exhausting small group discussions. It's surprising, it's a huge assessment, but each little topic may only have 3 or 4 people that are asked to agree. And the assessment is the consensus of the experts present, each of whom have deeply studied and understand the literature. But that's their most valuable. That was why IPCC was designed, to deploy this kind of authority based on the best scientific ethics as understood at the time. Well, knowledge and translation is a different matter. We understood it was important to communicate and get out of the technical language and probabilistic language and make statements that decision makers can understand, but we've all learned it's not enough to be correct. Well, if you can't make yourself understood, they won't listen, that's for sure. But if you, particularly in the developing world, neglect social justice and economic development, their concerns, they will neglect you. And if you're culturally insensitive, they won't respond. So a theme that will go through the rest of this talk will be, and this is discussed much in the policy literature, we do understand that trust motivates action. And personal contact, in my view, is the precursor to trust. Now, knowledge delivery, connect efficiently to governance. Make sure that what you assess is what they want, that you have very strong communications, and the decision-making regime and the decision analysis regime are, in fact, deeply coupled. So what these little mantras here are very easy to say and very hard to do. The right knowledge, the right people, at the right time. The right time is a key looming issue for the future. Deliver it when they need it and where they need it. Deliver it in forms they could use. Keep on delivering it. So as I look forward, and having made this brief dissection of assessment as the starter of adaptation, adaptation, and I think about the scale up to the rest of the world from our experience, I have worries about capacity, and not the kind you think of. Complexity, the certification, the delivery, the quality assurance, the timeliness, and the sustainability of the ways that we are currently doing things. So let's start. The capacity problem is not the one you thought of. How can the small science and technology community that's trained already to produce an IPCC report every 7 years, how is it going to meet the coming demands of hundreds of regions and millions of decision makers? How will that happen? There's the complexity problem. There's two versions of it, two forms of it. In, I think, lecture 3, I kind of made this hierarchical list of things that you have to understand sequentially, if you will, in order to get at the impacts of climate change. So once you know the globe is changing, you worry about the large-scale weather and ocean patterns and how they change, and then if you can get some handle on that, then you go to regional geophysical systems, watersheds, mountains, cryosphere, deserts. And then if you got that, then maybe you can say something reasonable about the changing ecosystems. And if you got that, you could probably say, and people do say things about regional technical systems, electricity demand and the like. But the thing is that the knowledge, before the knowledge bears on human problems, it has to go through these levels. And so that's the complexity problem. How do you accomplish that? Another version of the complexity problem, related at the other end, the bottom-up part. Adaptation is not suited to centralized, top-down command and control. No central actor, no leader, no committee, no agency can conceive of all the tasks ahead, and even more, how they interrelate. And so the complexity problem goes in the other direction. How do independently taken actions at, say, the regional community level, how do they roll up into higher levels of governance? Then there's the delivery problem. Eventually, we're going to have to meet the assessment needs of communities. In fact, of the decision makers or the technology and civil managers within those communities. And we will want to, because they are the ones that will do the innovation for their own resilience, and in a proper networking of knowledge that can spread very rapidly around the world. Now, to accomplish some of these things, I think the key enabler, once again, is quality insurance. But now at the local level, those local leaders are going to find themselves faced with decisions that they don't want to put off. They don't want to wait for knowledge to trickle to them through some complicated process. they'd like to find it right away or have their people find it right away and know that it is trustworthy. There's the timeliness problem. I already mentioned that we think the climate rate of change as measured by the temperature could well double in the next 20 or 30 years. That means that significant change can occur in the 7 years between IPCC reports as they did between the two reports on the Arctic. And again, the communities at risk can't wait for knowledge to cascade from global to regional to local. So, one suggestion, assessment should become an always-on knowledge management service. And finally, there's the sustainability problem. Plan to keep the knowledge in active use for 1,000 years. Very few human institutions last that long. Cambridge does. That's a knowledge management institute that survived. So also did the Library of Alexandria. And it has been revivified. Alexandria lived for about 700 years. And has been revivified. But in order to do that in the future, we have to think institutionally. Institution is not necessarily a building with walls, but it is an institution and network, a set of practices that have to be designed not only with the short term, but with the long-term future in mind. So what can we, having set forth these problems or issues that may afflict us as adaptation demands proliferate, what adaptive management would ask, the first question we'd ask is, what can we do with what we've got? So I'll list these things here. One idea that I think may become pertinent, at least in the Arctic context where things are changing so rapidly, research management should anticipate that the pace of climate change may accelerate, and they might choose to think in a new way about the funding cycle of research. One thing that afflicted us in NASA was the absolute division organizationally and philosophically that separated research and monitoring. And actually our experience is the minute a satellite goes up, its results are policy relevant. So you should provide in advance for when you know that the measurement's going to be significant. If it's good, provide for its entry into general discussion almost immediately. Flexible research grants. Things may change so rapidly that the proposal you wrote 3 or 4 years ago actually has you deploying the wrong equipment. And so I think you have to go back, at least in some areas, to have flexible research grants where more autonomy is allowed to the participating institutions and networks, core funding. And you might want to think of synthetic research, not always originality, in this area for these types of problems. So, timely knowledge synthesis. Here's I just decided I would tell you about the Earth System Science Partnership, which is a project of the International Council for Science, aka ICSU. They have just instituted a new program called Future Earth. And the question I have is, there are organizations like that out there, IPCC, ICSU, and so forth. Should they now, instead of waiting and assembling all the research results into one large volume, should they in fact synthesize and propagate the synthesis as soon as they think the synthesis seems mature? This, of course, leaves you with the question, who reviews the reviewers? Which comes up again and again. Next thing that I think would help would be to embed the assessment services in the internet. It'll help with the capacity, complexity, and timeliness problems. So we have to think exactly how to do that, but we do have some beginnings on the research side. One of the things that I think we should do is work towards a closer international and closer federation of the knowledge management services that we currently have. So now I will turn on to that. This is what suggestions about what we might do with what we have. I'll spend a little time now on what we have. We do have a worldwide communications architecture which suits the architecture of a global knowledge management enterprise supporting polycentric decision making. This happens to be the Global Lambda Information Facility. It's dedicated high capacity 40 gigabit per second lines connecting the major research centers of the world. And with the increasing capability of cloud services, I'm fairly certain that polycentric users with the appropriate translational material available could in fact access the basic result. A few years back, the National Science Foundation declared that they have a full suite of efficient knowledge management tools available, and it is now possible to proceed with greater assurance than before that you can do it all on the internet. There are a worldwide collection of data repositories that actually started with the International Geophysical Year in the 1957. So the World Data Center, 52 of them, in fact, various centers for the space data, and I was careful to put in the World Conservation Monitoring Center here in Cambridge, and there are many others. They don't interact necessarily with one another, and it's burdensome for you to find the data, but it is being looked after. There is, in fact, one federated research knowledge network that we do know about, and that is the NASA Distributed Active Archives, in which the space and other related data are connected in a series of archives that have big data pipes between them, so there's a greater possibility for data fusion. And finally, we have what is a rather thin governance system for Earth observations that could be built upon. This is the Global Earth Observing System of Systems, or the Group on Earth Observations. And it's underfunded and too small, but they are doing God's work. It's an intergovernmental agreement with many countries, more or less 80, I think. So, and basically what they're attempting to do is to provide access, to synthesize a common pool of data that are pertinent to 9 societal benefit areas. Read adaptation, amongst other things. And they're working quite hard on the standards that would allow for a common infrastructure to grow. So there are certain assets in place on which we could build. Now what's missing? These things, I think. And here I get speculative. But the problem, I think, is naive but responsible person has an urgent need to find information and knowledge. If he goes to Google Scholar, she has no idea whether it's any good, have no perspective on it. So what's needed is a kind of streamlined internet embedded certification process. Here's a certification problem that every non-citizen of the United States has had. This is the traffic jam at the U.S. border, where they are checking driver's license. Those drivers are uncertified. And so there's probably, in terms of the use of knowledge, there's a great backup while we wait to see that it's okay. Now, when I was at NASA, I got an idea about certification that is in my mind, and I suggest it to you for your consideration. NASA, years ago, invented a technology readiness level characterization in which they looked at specific technologies and the stages through which they must go before they are used regularly in spaceflight. And so if you look here, you start with basic research, you try to prove the feasibility, you do the technology development, you do the demonstration, finally you start using it, and then you have a record of launch. And so there are 9 levels of technology readiness that they can define. So is it possible that in the policy arena we could develop some similar thing? I don't really know, but I mean, I tried out this list of things just to see if there was a hierarchy that you could distinguish. So you've talked about it at a conference. It got published in the gray literature. It's now accessible on the net, but peer-reviewed publication. Peer review, by the way, the editors selected 2 or 3 people. And the question they ask is, are there any obvious mistakes in there? And is this worth the attention of the disciplinary community that reads that journal? Rather narrow certification from the point of view of subsequent use. But it gets interesting when you have multidisciplinary citations. The knowledge is propagated out of your own field and other people are using it. If it gets into a review article on expert synthesis, that's yet another thing. And then probably at that point you can decide whether it's clear enough that a non-expert person can access that knowledge and use it in their own community assessment, let's say. And then there's how it's been used, and finally best practice. I don't know whether these are the right categories, but I think something like this, if you were looking on the internet and you asked your assistant to figure out what to do about this or that adaptation problem, and they sent them off, this would probably help. There are also bibliometric indicators that you can use through things, and there are people already doing some of these things on the web of knowledge and big data. So you can make social maps, who's it's using it and why. And I think quite importantly, you can develop rankings for reviewers, citations, journals, wikis, and the like. And all of this kind of information doesn't replace human judgment, but they are indices. So all of this might come together at some future point in annotated search engines. The annotation is the important thing because it enables the knowledge system to connect to naive users, if you will, and it can turn it into a knowledge action system. Now, the final comments I'd like to make have to do with inducing action through social networking. Fundamental premise that I think is pertinent requires courage for non-experts, for political leaders, to risk their reputation and resources to act on expert knowledge that is unfamiliar to them because it is about a situation that neither they nor their stakeholders have ever seen before. It's harder for them to risk reputation and resource than it is to actually believe the assessment. And we're obsessed with the question of belief of the assessment, but I do think the key issue is the use of it. And so I'm going to argue that social networking conveys knowledge and motivation. And we have some examples out there already of what's happening, and there's a kind of hierarchical system, I think. The first that a lot of people know about is stakeholder consultation. Here's an example that occurred in the Baltic. They called it an assessment, but it was really a sampling, stakeholder sampling. It was an identification of problems and probably an identification of the way an assessment should connect with governance in that region. There are knowledge sharing consortia. The Global Adaptation Network was designed to do that. This is the Asian Pacific version. And they basically convey knowledge directly and to communities, basically to the scholarly communities in those regions. And there's been some success with APAN in the Philippines, for example, where there are receptive knowledge leaders in the communities ready to receive the knowledge. Then I think a knowledge sharing consortium is an effective way to go. At the other end, there are best practice consortia. There are this is where the decision leaders actually get together, and they're nervous about what their assessment and their assessors told them. Are they pursuing best practice? Are other people doing the same thing and taking the same risk? So they reinforce each other in best practice consortia. And we saw, particularly in the area of sea level rise and coastal cities, there's something like 40 consortia thinking about best practices for the management of sea level rise. So all of this is helpful, but it doesn't, in my view, make the central contribution to an adaptive management strategy. And so this is where our meetings in Kyoto at the Science and Technology Forum took place, had made a contribution over the last 5 years or so. And we actually talked about knowledge action networks that explicitly connect assessment and governance. What is knowledge action network? Well, I think they'll have many shapes and forms, and my social science colleagues will find a large variety of things that probably work. But the basic principle is face-to-face interactions amongst leaders of knowledge and action. So we thought of them as incubated internationally, empowered regionally. Usually they have to be empowered to do this, but initiated locally. That was an important thing. Initiated locally. So global, regional, local participants, a vertical structure, and they would be science, technology, and policy experts, regional leaders, local decision makers, and, importantly, professional secretariats that have professional knowledge translators and act in the terms of the trade as boundary organizations. And clearly, and we found this in Venice, if you keep talking over and over again, finally people began to understand each other at the depth that is required to motivate action. And we thought that this might be useful in the developing world. So in the next meeting, we tried to decide what some of the things Knowledge Action Network could do. Understand the local impacts of regional climate change, characterize the risks to the things that community cares about, have knowledgeable people on board in the team that can leverage other resources. And it's very important this vertical structure can interrelate decisions, we hope, at the global, regional, and local levels. Translate scientific knowledge, we talked about that. Communicate the need in culturally appropriate terms, we talked about that. Encourage the development of technical systems that can be used locally. Relay the local knowledge upwards in the hierarchy, and support the local leaders as they implement their decisions. So there are a few ideas about how we might attack the complex problem that will face us for the next centuries. Now, the challenge to the international community. The world can't wait for the top-down framework. People may want to try to construct it, but they'll break their heads. So we should take the first steps now. So try to incubate knowledge action networks, or things that have the same function. Move closer to federation of the knowledge management resources that you have. Connect the knowledge management and decision support infrastructures. That's the big weakness of the GEO at the moment, is they assemble the data, but they don't provide for access. And much of this can get started if you promulgate the standards for decision readiness and federation. So, and the key issue, I think, at least to getting started, is the standards. We think have all observed the rapid growth of the internet. It spread around the world. It was invented in the 70s, but in the 90s it spread around the world because of internet protocols. It's one of the few things that went global on the timescale that climate is going to be changing. So the question to start with, at least, is could knowledge management protocols transform how the world adapts to climate change? So I'm not the technologist here, but I made a list that of kinds of things that might need coordination. I don't think you can do them all simultaneously, but standards for taxonomy, basically what does your card catalog look like? Standards for the archives and how they should store data in commensurate forms. Standards for accessibility. You do have to deal with intellectual property, security, price, public release. And annotation standards. Finding standards. Just how do you help people find it? So the hope is that global adaptation, unlike mitigation, can be an emergent property of distributed local action if we do these things. And that, my friends, is the pot of gold at the end of the rainbow.
Thank you. Now, there's clearly quite a lot of ground covered in that lecture. It would be great if we have about half an hour for discussion, and it would be great to look into various aspects of that, but I'll leave that to you to decide whether you want to start with the end, as it were, questions of how this, what global system of knowledge management.
Well, yeah, I think, in some way, this is a group like CSAP with connections to the government and connections to decision making and connections to the academic community could take upon itself kind of organizing around some of the issues involved with trying to build this big vision. And that's, I think, for policy institutions with good connection to leading science. And I think that it has to be both.
Questions? David Quigley, Founding Director at the Centre for Science Policy. Charlie, thank you very much indeed. We're absolutely delighted to host you here. And thank you for an extremely interesting lecture. In North Carolina, legislation has been passed effectively limiting the ability to plan for sea level rises to a linear extrapolation in the last 100 years, which means that some of the things we've talked about here may well overwhelm North Carolina before they can actually put any adaptation measures into place. What do you make of that as an issue, and how would you deal with it because it has to be dealt with within the framework you're proposing?
I knew you were going to ask something about that. I think you will find that that is a decision, a governance apparatus that is unready to couple to assessment. And probably in this game you have to take progress where you find it. So if they fall behind, but if there's enough interconnection and measurement and understanding of what the others are doing, eventually they will, presumably as the sea level wipes out their houses at Cape Hatteras, that they will eventually catch on. And then you have to be forgiving of that. And in the meantime, what's happened, this is all a part of the poisonous political and ideological atmosphere that rules at the present time. And so you would hear, for example, this talk would be considered alarmist. We're not ready to make that decision. Well, Alarmism means that, yes, you are not ready to make that decision, but others can and should be, and we should empower them. I don't see any other way to do it. We're not going to get uniform global agreement that we should all adapt in lockstep, do we? Because the problems are all different, and they connect up to different decision apparatuses, different economic concerns, and so forth. So adaptive management, take progress where you find it, and make sure that everyone else knows that it's progress. And one of the key points, I think, will be to see the local leaders making progress and having done it on their own initiative. The global problem, hegemonic knowledge has its place in this game. It's important, but I don't think it's it's not the sole thing that we need to make progress in this area.
Richard Gilby from Queens. I just wonder what your comment would be on the personal decision to become a vegan. In other words, not to eat meat or dairy products.
Here, I think I would say two things. If that were a large enough effort to actually offset the production significantly of methane and so forth, then I think it's a step that people can make, and it symbolizes, I think, people's personal commitment to seeing a larger social transformation that needs to take place. At the same time, thinking like David Mackay, probably it doesn't operate at scale. So it contributes to your and the perception of wider support for measures like this, but you really need to achieve savings from agricultural methane around the world. You need it on rice production in Southeast Asia, where rice is as appealing there as hamburgers are to Americans. So it's I think, an important symbolic statement, and I will accept progress wherever I see it, but you have to work to make sure that it can operate at scale.
Hello, thank you very much. Mark Wainwright from the Open Knowledge Foundation, and I was happy to see that one of the things that you mentioned was data repositories, which is something that we're very keen on, and in fact an article that they published this week argued that for progress in knowledge, especially in cross-disciplinary areas, we need scientific data to be published openly, not just after the project at gathered is finished, but as the data is gathered. And what that means.
That was part of my. The words I would use to do that one would say that I used it in the formal sense that to reduce the gap between research and monitoring, or research and active use.
Absolutely, and my job title is Open Data Evangelist, so happy for you to be doing my work. I'm going to ask you something else. I mean, what you've been talking about today is how to connect together the scientific progress and understanding and policy and so on. Like all those people that you mentioned being have talked to you who said, I didn't realise how complicated the problem was. I guess my strongest reaction to the previous lectures has been not so much I didn't realise how complicated it was, but I didn't realise how bad it already was.
Yes.
Now, if you're in a car and you're hurtling over a cliff, you might have the best knowledge deployment procedures in the world, but they're not going to stop.
Yeah,
from hurting you. I have any assessment. You haven't sort of given us a.
Yeah, well, I mean, look at the question of adaptation, for example, and let's consider how the developing world will, as presently laid out, would think about it. The UN, through the UNFCCC, has voted about $100 billion fund to go to developing countries for the purpose of adaptation. That's real money. assessment is not real money. It's something useful to do. But the allocation of that money, in my view, well, first of all, developed nations don't have any real incentive to, at the selfish level, a real incentive to do it. But they would raise technical objections, like why should I pay for something that hasn't happened yet, whose nature and cost I don't know? And there will be issues like that. And so the ability for a region or a community to get together its own assessment, motivated by its own needs, get together its own assessment and have it certified, will then provide the basis for larger funding issues. And then you need, at that point, having imagined a little community doing that, the big aid agencies and the governments aren't going to know of all of these. Who has the most urgent problem? They all sound urgent, right? And yet they have to allocate funds. And so that's where the horizontal level, the global knowledge management and communication services, have to come in.
I was asking whether the problem is so bad that it's going to be...
It may be, but we don't have any choice, right? How are we going? We're living in this world. It's changing. We made it change. We're not going to be able to stop the change for a very long period of time, and we don't know where it becomes intolerable. So we don't have a choice. We're living in this world, and you can lay down and just enjoy the beach, and then, or you can decide, try to figure out what we are capable of doing now.
I'm Michael Priestnall from Cambridge Carbon Capture. You very eloquently laid out a sort of an approach and strategy and reason why adaptation can come along. We can address it, and it's a large part of that. It's just as you were just saying. It's about the incentivisation at all sorts of local levels, coming down to individuals, individual companies to take action, incentivised by the consequence of not taking some action in relation to adaptation. I was just wondering whether your line of thinking and view is that really that doesn't apply for mitigation, and that all of our attempts at bringing in policy and mechanisms to address mitigation don't translate to the individual and the individual company that has to make a decision about doing something about mitigation.
Well, mitigation decisions, as I emphasized, are much larger scale. But the word mitigation now implies both long-term and short-term actions for the first time. The carbon problem is very hard, extremely hard, inconceivably hard, because you're talking about 50 years of ongoing climate change. If you knew how to reform our energy system, it would take 50 years to replace all the infrastructure. Forget about reaching a global decision to do it for 193 countries. And even after you've done that, those people who took all the sacrifices and reduced their energy consumption and changed their economy, they won't see the impacts on the climate. So the incentives are misaligned on carbon. There is an area of mitigation where they can be aligned, and we can make some progress in the coming decades. And that will be to look at other agents that we are putting into the atmosphere that also warm the climate. And if you look at the other greenhouse gases, the other greenhouse gases, methane, lower atmosphere, ozone, black carbon, just the other greenhouse gases are 40% of the total. And we now think that black carbon is the second largest warming agent after carbon dioxide. So black carbon goes away in 2 weeks. If you stop polluting, the atmosphere would be clean. Methane has about a 10-year lifetime. So you can work on those, and you make some progress, and you slow the rate. I mean, it's concerned with the rate of climate change that's facing us as the level at the present time. You could slow the rate for 20, 30, 40 years, however long it takes you to enact the measures that will reduce the short-lived climate forcing agents. And that then buys time. Things aren't quite as bad on the adaptation front. Maybe you can offset some of the worst effects and give time for two things that are probably critical to the carbon problem. One is actually new technologies and the spread of them. And the other one, I think, is this whole issue that you brought up about the change in social views. And so if you can slow things down for the next 50 years, maybe we can accomplish those things on carbon in the next 50 years, at least, and suffer less as a result.
Mike Bissell from Geography. Thank you, Charles. There's a very comprehensive global structure that you're imagining there, which would be impressive if it were possible to build it. But it seems to me that the adaptation is problematic in many ways, even within that structure. So with mitigation, we have a single, very well defined, easy to understand target, which is to reduce the amount of greenhouse warming. Adaptation is not clear at all what it's for, or what the goals are, and those may be multiple goals in lots of different places. But to assume that providing people with knowledge will make it possible for them to adapt is possibly not necessarily true, because people are extremely good at taking very detailed knowledge and picking out of it the bits which support the things that they want to support, and discarding other things. So if we have lots of local actors who are all designing their own adaptation strategies for whatever their possibly conflicting political goals may be, how is this structure going to avoid the tragedy of the commons type of situation? People, for example, on Danube in one country see a really good opportunity to adapt as they see it, provide themselves a huge benefit, and downstream in the country next door, it's terrible.
Well, there is, of course, enabled by this structure, the horizontal and vertical communications simultaneously, there is the possibility for communication across the higher levels, if you will, the higher levels of abstraction and so forth within the system. And so I don't think you're going to find ultimately that if there's social learning and people learn about what's successful in adaptation, I think it will spread. I know here in the UK, for example, there is devolution. It is happening, devolution of water management and other things. And there's a great deal of worry that at the lower levels of government and so forth, there isn't the capability to handle the issues. That could well be a worry. But this is one of the reasons why you might want one of these vertical social networks that kind of speed that process of learning along.
My name is Ken Mackay. I found your series of lectures very inspiring, Charlie. I've been active in trying to move towards adaptation and climate change for over 20 years locally, and locally in this case is in a city up the road from here, 20 miles away, city of Peterborough, where we've made some progress, but my God, it's been slow and difficult to get things moving. I think we've got momentum now, but I wondered if you had any advice for those of us here who would like to get more action going on how we can increase the pace.
Well, I obviously focused on how the scientific and science and policy community, what it can do to increase the pace. And I didn't think deeply about it, except that promulgate success and build some sort of horizontal, build a consortium of best practice. Go find the other early adopters and talk to them. That'd be one suggestion, and that I think is being pursued in the sea level rise area, where sea level rise is the one issue that everybody can visualize. Its effects are localized. You know who's going to be affected, and they're pretty clear to understand. And so there's an awful lot of action on thinking at the government and decision-making level. There's a lot of action, and there are lots of best practice consortia out there in which they do that. But I think, we have... I suppressed the slide, but it had a beautiful picture because San Diego has taken the lead and joined a consortium of Mediterranean cities. Barcelona, all cities that have a eastern boundary current, have a kind of Mediterranean climate. There's Santiago in Chile and in South Africa. And so they've all gotten together and said we have a unique climate and a unique climate relationship with the ocean and a unique ecology. And so they've gotten together. But it's the civic leaders, and they love to go to each other's beautiful cities. They're amongst the most beautiful cities in the whole world. So then there can be more than one reason to make progress. In fact, big things usually don't happen without multiple reasons, both big and small.
Thanks very much, Charlie. I'd like to pick up on this notion that adaptations can be in conflict with each other. So in other words, people trying to adapt may actually, in some sense, fighting over water is adapting.
Yes.
It can be in conflict. But what do you think we can do to the conflict with mitigation? So in other words, how do we ensure that adaptations, which could be enormous projects, geophysical projects, or geoengineering projects doing big things and therefore spending potentially lots of energy, are not actually contributing to carbon?
Yeah. So how do we ameliorate the conflict between adaptation and mitigation? Now, I have to admit that with the exception of the interaction between the short-lived climate forcing agents on the mitigation side and adaptation, that I haven't thought much about that problem. But I think the essential question, which I don't know the answer to, would be, are we running as fast as we can on mitigation at the technical level, considering what's possible politically and all of that? And also to recognize that the time scale of that problem is much longer, 50 years or more. And so I think looming in the back of my mind, which may not be correct, is this presumption that somehow, even if we spend money on adaptation, it's not going to compete with mitigation. We have to do both. And I think there'll be different interest groups and different incentives. They're kind of disparate political discussions in a funny way.
Thank you. So in a second, I'll invite you to join us next door for a drink and to continue the conversation. But firstly, I would like to thank everybody for coming, and particularly, as we said, that special club of people who've been to all of the 6 lectures in addition to...
Yeah, they should get a medal of some kind, the CSAP medal with the oak leaves.
And thank Christ College for hosting this series. And other thanks that I'd like to make particularly warmly is to Ursa Marley, who's
yes, indeed. Thank you, Ursa.
Researcher at the Centre for Science and Policy, who is doing work trying to understand these relationships, and in addition has been working with Charlie Kennel during this last term as visiting research fellow. And thanks to Ursa, you'll be able to see Charlie's slides and hear audio recordings of these lectures. So
and
those unlucky few who didn't make all 6, you can catch up through that. But of course, particularly and especially want to thank Charlie Kennel for his quite inspiring series of 6 lectures that I'm sure for us, and I think I've already heard from several people in the audience, for you too, will provide food for thought and inspiration for action in the months and perhaps in the years ahead. So from all of us, thank you very much, Charlie.
From all of me, thank you. When do I have a chance to speak to such a highly educated and intelligent general audience in one of the great academic centers of the world? It's been a great privilege for me, and so I'm very thankful to you all for your attention. It was inspiring to me. Thank you.